Right, so I'm going to be talking about generative AI copilots, and I'm going to be talking about fine-tuning large language models, and specifically, with regards to the CRM transcript analysis problem, how does it apply? Okay, so quick intro. I'm Prabhakar Srinivasan. I head the AI practice at Synechron, and I also manage the innovation team in Bangalore. Synechron is a company with 15,000 employees spread out across 19 locations globally. And we are headquartered in Pune, and we have 2 centers in Bangalore also. We're heavily invested in AI, and over 2 decades, we've done a lot of good work in the fintech space, and now we're also making forays into the high-tech space. Okay? We also have a booth, a stall here, so for those of you who have not had a chance to visit the booth, I welcome you. We have a team headed by our country head, Mr. Harisha, and my innovation teammates are also there, so my team and I will be there. So I'll try to cover as much as I can today in the 45 minutes available, and then if you have any follow-up questions or you want a deeper dive, you can always join us in the booth. Okay? All right. So I'll be talking about 5 things today, right? We'll talk about generative AI and how it applies to various business functions across industry verticals, okay? And then I'll give you an overview of generative AI and LLMs, okay? But I'll connect that to what is relevant for this particular presentation, which is the choice of LLMs for CRM transcript analysis. Then we'll talk about the challenges in the CRM domain when you want to analyze transcripts. Then we talk about why you need to fine-tune versus using proprietary LLM APIs and the actual mechanism of doing it, how we fine-tune LLMs. Okay? So there is a demo of two topics at the booth. One of them is on CRM transcript analysis, but we also have another demo which is about applying generative AI for SDLC. Okay? So I encourage you to check out both the demos, good value additions. Okay? So this particular slide talks about basically the McKinsey report that came out 2 months ago. You might have already heard about this. It's a very popular report. They did an extensive survey across companies and across industry verticals. And they try to assess the value proposition of applying generative AI in various business functions. Okay? So one of the areas where the McKinsey report highlighted a maximum impact for generative AI was in software engineering. So in the SDLC, the development and the testing phase, you're going to see a lot of disruption when you apply generative AI. Although when you say copilot nowadays, people connect it related to the Microsoft GitHub Copilot, it's not restricted to that. You can actually think of Copilot as any application that removes the repetitive tedium associated with many manual tasks in a business process. So you can think of a Copilot for marketing, you can think of a Copilot for supply chain, you can think of a Copilot for CRM, which will be the focus of my talk today. Okay? Something interesting about Synechron is we actually develop a lot of prototypes, a lot of applications, and we pilot it internally. So we're actually developing applications that our internal legal teams are using to analyze contracts. We're actually developing applications which our HR team is actually using to find out if a JD is appropriate for a particular role that you have open, if a resume is appropriate for a JD, and if you can score a resume given a particular job description. So these are all things that we're piloting internally, and we're also offering it to some of our clients. Okay? So a topic that came out from the survey, from the report was customer support and customer operations was another area which was going to see a lot of disruption. Closely associated with customer support is also tech support and network operations center support. Okay? So these areas, you'll have a lot of manual steps, and generative AI is going to remove a lot of the tedium involved in the process. Okay? All right. Product R&D is going to see a massive shift. You're going to design automobiles and interior spaces just by prompting. That's already happening. And these ideas are actually already put into motion in many startups. Okay? And in supply chain and operations, we've actually developed some capabilities where we can actually score vendors. We can actually fetch information about vendors using generative AI and reduce the risk in your supply chain. So all across the board, you're going to see generative AI playing a very disruptive role, and it's going to be the new normal. Okay? All right, let's now talk about the challenges in the CRM space. So a few months ago, one of the customers from an insurance sector, they approached us and they gave us some requirements. And they said, we have a lot of transcripts of customer conversations with our agents. These are archived, and we wish to be able to summarize the transcript. Okay? You might think summarization is a very easy task, but if you take any screenplay of a movie or a TV series and you read 1 or 2 pages, and then you try to abstractively summarize it in your head, you'll find that it's actually very challenging because of the jumps in the conversation, and you're wondering who said what. So what is actually cognitively challenging for the human is actually very easy for the LLM, because as part of the training corpus of data, you have large dialogue data sets which are included. So they're actually very good at doing what we find very challenging, which is summarization of dialogues. Okay? And then so all of us have been in the scenario where we talk to an agent, and then the agent offers a resolution for a problem that we reported. And then they'll say a technician will be at your premises at such and such time to fix the problem. Okay, the call is concluded, but then there's no record of that pending follow-up action. And if the agent doesn't follow up, that leads to customer dissatisfaction. Right? So being able to detect these follow-up actions and take action accordingly and hold people accountable for it is a very important requirement that came up. Thirdly, non-compliance. So the whole CRM world works with a lot of standard operating procedures. Tech support, NOC support. Given an issue, how do you resolve it? What are the escalation points? All of this is defined in a standard operating procedure or a set of SOPs. So any deviation from that will lead to non-compliance. Okay? And the penalty for non-compliance is possibly removing the agent from the workforce and sending them back into training, or at an extreme case, it could lead to termination of employment also. So detecting non-compliance of agents was an important challenge for us. And then summary dashboard. So if you're a consumer electronics device manufacturer, and there are a lot of tech support related issues, you'd like to be able to see a dashboard with how many calls arrived yesterday, how many of them are related to battery related malfunctioning as opposed to screen related issues, or as opposed to firmware related issues, etc. In order for you to even build that kind of a dashboard, you first need to be able to extract key phrases. In NLP, we have named entity recognition. So you can actually extract those entities, and then you can build those aggregate dashboards. So this is another powerful feature. And sometimes when you visualize the data, half the battle is won. You can get on with holding people accountable and resolving the problems. And the usual use cases like churn prediction, sentiment analysis were all listed. The last one was kind of interesting. CRM data is riddled with PII data. Right at the beginning, you're expected to actually verify your identity. You're supposed to share your Aadhaar card number or your social security number, mother's maiden name, and all of that. So all of that is actually transcribed from speech to text using some applications, and it ends up in a dialogue as a transcript. Right? Now, this PII data, or personally identifiable information, has to be elicited in a very ethical manner, archived, and carefully managed throughout. You cannot allow any data leakage. Companies can go out of business quite easily if data leakage happens in this day and age, because there are laws which are much stricter now compared to many years ago. So GenAI can also address these kind of problems, and my team is actually building these capabilities. So a bundle of all of these capabilities will take your CRM productivity level high, and this entire suite of applications acts as a copilot. Okay? So that's the productivity gain play that we're after. All right, a brief overview about generative AI to make sure everybody is on the same page. Generative AI is a branch of AI that creates novel, original content, and it can create content in various formats: images, audio, video, text, and even code. Okay? It's basically a very sophisticated imitation engine. It's trained on a lot of samples, and it's going to try to replicate the patterns that it saw in the training data. A few years ago, we used to create one model for one NLP task, but now we're in an era where you have one model that can achieve many NLP capabilities. Okay? You package all of the NLP capabilities in one model, and typically, if it's more than a billion parameters in size, you call it a large language model. And ChatGPT has over 175 billion parameters. So in a sense, it's become a generalist, but sometimes there's a need to actually create a specialist model, and that brings up the whole topic of fine-tuning these models. Okay? Big tech firms like Microsoft, OpenAI, Google have developed the proprietary LLMs. So there are two ways by which you can access it: proprietary LLM APIs or local LLM APIs. You can download these LLMs from Hugging Face, which is a great portal to download models from. And then you can actually run it from like a high-end gaming laptop. Some of the models actually run quite well in a gaming laptop-like configuration. Okay? All right. So the visuals that you see, the images, I had these images put there to illustrate a point that when you scale in the number of parameters for any given model, like T5 is a very popular model, Llama 2 is a popular model, as you scale, new capabilities get unlocked. Okay? So the basic model with maybe 8 billion parameters might achieve 3 or 4 NLP tasks like arithmetic or question answering or conversational AI. And then as you go to a much larger size variant of the same model, you're starting to see it can actually do interesting things like joke interpretation and things like that. You may not require it for your business function, but those features are there if you need them. Okay? All right. So this slide talks about the evolution of LLM. And this is a nice segue into the next slide, which will talk about a heat map of capabilities of LLMs also. Okay? So in 2017, Attention is All You Need, a very important paper came out of Google research. That spawned a new wave of research, and the new neural network architecture called Transformer was introduced. I think all of you at some point would have used it, and there are many in this room who are probably practitioners. You're programming with transformers on a daily basis, so you know the power of it. There was a fork in the road, and you now had encoder-only models, and you had encoder-decoder models, and then decoder-only models. The ChatGPT family of models, GPT-1, 2, 3, 4, and models like Bard and Lambda from Google, they are all belonging to the GPT family, or the decoder-only family. Something interesting is they have the characteristic of actually look back and do the auto-regression on the model itself. So that gives you the ability to be really powerful at certain skills, which we'll see in the next slide. In the middle branch, you have Flan T5. It's from Google, T5 and Flan T5 and variants of T5, which is from Google. These are generally called auto-encoder models as opposed to auto-regressive models, which is the ChatGPT family of models. T5 models, they excel really at, they do really well at summarization kind of tasks, okay? And that's my segue into the next slide. But before I go to the next slide, I wanted to mention that some of these models like Flan T5, the base variant can actually run quite well on our laptops. So there's a lot of potential in actually taking these lightweight models and being able to fine-tune them. So this heat map is actually a good representation of how you map or how you select LLMs and map them to certain tasks that you wish to achieve. So when you want to fine-tune for a particular NLP task, you don't arbitrarily choose an LLM and try to fine-tune it. So if you're trying to do summarization, for those of you who can't read the fine font size, these are the columns: information extraction, text classification, conversational AI, summarization, machine translation, and content generation. There are many hundreds of such NLP tasks, and if you look at T5 seems to be, it's an auto-regressive model and auto-encoder model, and it's really good at summarization. So all the dark cells actually tell you which LLMs are really excelling at what kind of tasks. This will be very useful because later on, if you build applications and you're trying to solve a summarization-related problem, you know which LLM to pick and fine-tune. Similarly, if you're building a chatbot and conversational AI, you're better off looking at auto-regression family or decoder-only family of models like the GPT family. All right. So the T in GPT stands for transformers, and it's generative pre-trained transformers. So it's worthwhile to have one slide on it, of course. So transformers basically are a breakaway new architecture in neural networks. We were very familiar with convolutional neural networks and recurrent neural networks and LSTMs and gated recurrent units and so on. And then in 2017, this new neural network architecture was proposed. It was not 100% novel because there were shades of that already in 2013 from a Yoshua Bengio paper, and also in 1992, the seeds of what an encoder and decoder are was sown way back in 1992. So when this model came out, it actually beat all the benchmarks in document classification, kind of classic NLP problems. It was 40% better in terms of efficiency, and computational efficiency, it was like 60% efficient. So it held a lot of promise. Okay? It still does. Then we started applying it from NLP to speech and vision and other domains as well. Okay? While this was happening and the research community was very excited about transformers, we also got really good at tokenization, embedding, and also working with pre-trained networks. Okay? Pre-trained networks, somebody's already gone through the trouble of creating the pre-trained models, and we don't have to go through the same process of training the model, and we usually train and then we do inference. You don't have to train it. You can actually start doing the inference right off the bat. And transfer learning, that was another thing that became very popular in a few years back. You could actually take a model which was really good at performing a particular NLP task, and then give it a slightly different NLP task and ask it to perform on a different task. It doesn't have to be NLP, it can be a computer vision task too. And transfer learning is a paradigm which forces or tests or challenges the model to perform new tasks. Okay? So all of these things came together, a nice confluence of this, and in 2022, we had enough critical mass of research that we could actually launch into large language models. It was just a matter of scale. It was inevitable to happen, it happened. And in November of last year, ChatGPT was launched. After that, we've seen plenty of open source projects come out. The latest one, which is very exciting, is Llama 2. We've done a lot of experiments with Llama 2, and many of our models are either Llama 2 based for fine-tuning, or they are FLAN-T5 based. Okay? All right. I'll briefly touch upon tokenization and embedding. These are low-level data pipeline operations, which anyway we have to do. Tokenization is a way by which you can take variable length strings and chop them up into smaller, manageable chunks. There are several algorithms available for tokenization. You may do word level, sentence level, and also sub-word level. ChatGPT uses a very popular technique called byte pair encoding, and it's a very powerful technique, especially when you have out-of-vocabulary context and tokens. Even if the model doesn't know the meaning of a particular word, it can actually do something similar to stemming and go down to the base meaning by breaking down the word into subwords. Okay? And models work really well with fixed length vectors, fixed array of floating point numbers representing tokenization, representing the raw text. And so embedding is also important. So for every word, you actually have some 768 or 1024 tokens, 1024 tuple vectors. Now, why you need to keep in mind, the key takeaway from this slide is that tokenization and embedding go hand in hand with the model that you're using. So if you use the wrong tokenization for the wrong model, it won't work. There's a compatibility issue. So for Llama, you have a tokenization and embedding pipeline. For FLAN-T5, you have a similar compatible variant of it. You can also fine-tune ChatGPT, and ChatGPT prescribes its own pipeline for tokenization and embedding. Okay? Something to keep in mind when you're building these pipelines, because once you build that pipeline, you can go through several iterations of training quite easily. Most of the low-level primitives have all been addressed. There are a lot of abstractions available. Libraries are available to take care of all the heavy lifting. So luckily, we don't have to code all of this and reinvent the wheel. All right. So let's talk about why we need fine-tuning. Okay? So all these models, ChatGPT, Bard from Google, all of these models actually, out of the box, support many NLP tasks. Okay? Text summarization, machine translation, conversational AI, question answering, sentiment analysis. They support it right out of the box. You don't have to program anything. But then these are generalist models. These are not specialist models. Okay? Let's take one example. You have great support for 80 to 100 languages in ChatGPT. So you can actually have ChatGPT generate code for you in different languages. Okay? But there are new languages which are coming out, programming languages which are coming out, okay, which are not covered. So there is a reason to actually take a model and fine-tune it with an annotated data set. That's always going to be a very powerful use case. When you have new knowledge base and you have to train the model, fine-tuning is going to be relevant. Also, we are starting to see that smaller models like the Google Flantify, it's about 4 to 5 GB of hard disk space. It's a very small model, 250 million parameters. I'll show you an experiment where we noticed it was a case of David versus Goliath. It was actually defeating even ChatGPT's published benchmarks. So when you move from a generalist model, which promises to do many things, to a specialist model which is fine-tuned to do only one thing, that specialist model can actually excel at that one NLP task for which it was trained. Okay? So improved performance, domain adaptability. Domain adaptability is very important because in a space like CRM, you're going to have new SOPs coming up all the time. Business constantly keeps adapting, right? So you have new standard operating procedures. So when you have a model, you can quickly iterate, take the SOP, train your model, put it into production very easily. So it gives you that flexibility. All right, so let's now talk about how we actually fine-tune. All right, so let's look at this example. SAMSUM, S-A-M-S-U-M, is a very popular data set. There are many dialogue data sets which are available. Okay? The training corpus that goes into the training cycle of ChatGPT, like LLMs, includes data of many flavors. You have dialogue data sets, you have code-related programming, software-related data sets, and you have a plethora of data types, data set types. Okay? Now, this particular data set is everyday commonplace conversations, and these basically have two columns. This is one sample that you see here, dialogue and summary. If you're wondering how the summary column is created, a human has actually gone through the dialogue, and they've done abstractive summarization in their minds, and then they've created this content. Okay? So this is a very painstaking task of actually creating these kind of gold standard data sets. Somebody has created that. You have around 20,000 samples, I think. And this has become a benchmark data set for summarization, and all LLMs use this. And then there's another data set called XSum. These are very popular dialogue data sets. Okay? So once you have this data set, we go through the traditional machine learning, the training cycle. So we actually take the Samsung data set, and then we fine-tune with Flantify. And what you get from this process of fine-tuning is basically a dialogue summarization model. Now, this is a specialist model. So it loses its versatility. It may not do language translation. It may not generate code for you after that. So it loses a few of its powers, but it gains power in one aspect, which is it becomes a brilliant dialogue summarization model. Okay, so here's the comparison of Flantify's base model, which is fine-tuned, and these are metrics which came from Synechron team's experiments. So we got a Rouge score. R-O-U-G-E is a metric. Rouge is a metric that we use to measure this. We got a metric of 40.29 for Samsung dataset for the Rouge L. The link to the paper is given below. For ChatGPT for zero shot was 28.15. So this is an unfair comparison, as you might have guessed, because we're comparing a fine-tuned model with a zero shot. We should ideally compare it with a fine-tuned ChatGPT. But this gives you a sense of what you can achieve. What we want to target is getting close to 50. 50 is an excellent benchmark for Rouge score. Okay? You have Rouge 1, Rouge 2, and Rouge L. Rouge 1 is basically unigram. Rouge 2 is bigram. And then Rouge L is longest common subsequence. Basically, what you do is you take if you go to the previous slide, you have a summary here, a human annotated summary. The model will give you a summary. So you line them up left-hand side and right-hand side, and then you see how much of overlap is there. If you get a 50% overlap, then that's for every word that you see in the human annotation, if it appears also in the model, that's your Rouge 1 score. And you also look at pairs of words, bigrams. Okay? So we were quite happy with this, and of course, we won't stop with 40.29. This is a base model. So when you have more parameters, you expect the skill to go levels. So we have base, and then you have large, extra large, and double extra large models also. But the nice thing is this model, all of the training and inference, all of this was done on a laptop-like configuration. So going forward, you're going to see that fine-tuning is going to be kind of a go-to strategy when you want to build these bespoke models. Okay? Now, the same data set, now you have an extra column. Okay? You're wondering, what is this new column? How did it appear here? So this column is titled Follow-up Action Prediction. So this is the second experiment that we did. And we actually took the dialogue column, okay? Sample by sample, we sent it to ChatGPT, and the model that we used was Text DaVinci 003, and we got an output from ChatGPT, okay? There's actually a name for this technique. Does anyone know the name? Where you use a large model, and then you create synthetic data sets using the large model to improve the performance of a smaller model. Yep, knowledge distillation. And there are different types of knowledge distillation. The one we used was offline distillation. There are online distillation, hybrid distillation, many techniques are there. So we use this technique to create the follow-up action. So now, as you can see, we have a dialogue and we have a follow-up action. So we can continue with our traditional machine learning cycle. So now it's color-coded differently. So we start with the Samsung dialogue data set. And then the prompt is, what is the pending follow-up action for the following dialogue? That is the prefix that we added to every sample. And then we gave it, and we created a new data set, which has the Samsung dialogue data set with knowledge distillation. And that again, is sent to FLAN-T5. And your generic FLAN-T5 now becomes a specialized follow-up action predictor model. Okay, that's another model. So now you're going to have a bunch of models which are all specialized to do one task only, and that do really well. Okay? All right, so let's look at another example. So here we have another data set, but something interesting is going on. The dialogue is actually completely synthetic data, and then non-compliance is the target that we're trying to predict is also synthetic. Okay? So we use GPT-4, it's one of the best models out there. So we use GPT-4 this time, and we prefixed it to the prompt to generate the synthetic dialogue between a customer and an agent. We also asked GPT to generate the non-compliance, to detect if there is a non-compliance and also provide the explanation of the non-compliance. Okay? If you're wondering what that prompt was, here's a screenshot for those of you at the back who can't read it. I'll read it out. Create a dialogue between a customer and a customer support agent where there is a non-compliance on the part of the agent. The agent tries to upsell premium services without resolving the pre-existing complaint regarding poor internet connectivity. Okay? So this is a classic example of non-compliance, and we've heard many stories where agents are incentivized to sell, so they actually they don't fix the problem at hand, but then they go on to try to upsell more premium services. This is 1 out of 30 scenarios of non-compliance that we are covering. So for every one of the scenarios, you can actually use prompt engineering and knowledge distillation, create a synthetic data set, and you can create a model. Will this model be there? Will it have a long shelf life? Probably not. After a couple of seasons, the business will come back and update this standard operating procedure. New cases of non-compliance will be discovered. You can even ask business to provide you ground truth. You don't have to always rely on knowledge distillation, but at least you have a backup plan ready, you have a model ready, and you can always enrich the data and make it smarter. Okay? Then on the right-hand side, we have a prompt. Determine if there is a non-compliance in the above dialogue. If so, explain the non-compliance. So, so it says primary concern not addressed, failure to acknowledge, customers experience neglected, interruption in service flow. Okay? So this is what we use to train our model, and now we have a new workflow where we don't use a publicly available dialogue data set. We use a knowledge distilled dialogue data set, and we use prompts, and we work with GPT-4, and we create a data set, and we fine-tune. The result of this fine-tuning workflow is a non-compliance predictor model. Okay? All right, so this brings me to my last slide. Okay, I have a live demo also available in the booth, so you can actually check out this application. So this is a conversation between Bob and an agent, Chris. Okay, and Bob is considering. Bob is actually checking to see if the advertised price is still valid, and he wants to transfer his cellular plan. Okay, and Chris says that price is no longer valid. And then Bob says, well, you did advertise, so aren't you supposed to honor the price? So they go back and forth, and then Bob hangs up, and he's unhappy with the customer experience. So the summary is, this is an output from our FLAN-T5 model. Bob is considering switching to Chris's company for a better deal. Bob saw his ad for an unlimited cellular plan that included unlimited calls for $19.99 a month. Chris can offer Bob a similar plan at a higher rate. And the follow-up action is the dialogue ends with Bob expressing his dissatisfaction with the company's pricing and terms. And in non-compliance, the model actually detected that it's false advertising or misleading advertising, right? So this is quite helpful. For a CRM manager, you now know all the potential non-compliance. So normally when you get on a customer service call, you hear this automated message in IVR saying, this call may be monitored for quality assurance purpose. Only about 2 to 3% of the calls actually, in reality, get monitored. It's very difficult to go through thousands of calls on a daily basis. The insurance client that we are working with receives 10,000 calls on a daily basis. So it's really not possible to cover the entire archive of dialogues. But using GenAI, you can actually detect non-compliance, you can detect if there are any pending follow-up action, and bubble those dialogue transcripts or those tickets or cases in priority and start focusing on them and provide resolution. Okay? And that basically is the conclusion. Yeah. Yeah, that's, yeah.
What has been the size of the data set to fine-tune?
So we typically use around 2,000 to 3,000 samples, and that seems to be good enough. If we have more, we'll always integrate. So these models don't perform well if you have only 100 or 200 samples. So you really need to extend it. 2,000, I think. Yeah. So actual numbers we can tell you at the booth. Do join us, and we'll give you a demo of this. Yeah. In fact, the developers of this particular application are also here. Abbas and Kapil are in the audience. So feel free to connect with them. They can actually give you all the details. Okay.
Sir, here.
Yeah.
Hello.
Yes.
Here in the front row, please.
Here.
Yeah.
Yeah. Okay.
Sorry. Yeah. I saw this slide where you have done the LLM evaluation and the selection. So, today's age of information abundance, so which is the right source to refer to really understand how to evaluate different models?
Right. So this particular, are you talking about this slide?
Yes. The
This
other
one,
one.
right? This one?
Yeah.
Yeah. So this one is from a Medium article, and it's at least 6 months old, I think. A lot of new models have come out.
Okay.
I don't know. I would just keep watching that space. We are subscribed to Medium, so we get a lot of articles.
I do regularly follow Medium. Yes,
Yeah.
I did see this slide as well.
Yeah.
This article as well. But going further, if you really want to evaluate newer models,
Right. So
is there any other source, or is it only Medium?
Yeah, so one of the things we do is we go to Hugging Face, we look at all the open source models, we read the model card, we understand if it's auto-regressive or auto-encoder model. We understand all of those things. And once you understand what the author is trying to say in this article, you can extrapolate. So once you go through the new models, like when there's a lot of buzz around a new model like Llama 2, go to Hugging Face, read the model card, understand, and then if you know where it fits in this evolutionary tree, it fits in the decoder-only branch, and these models are supposed to be really good at conversational AI. So you can connect the dots. It's Yeah, I wish this author kept refreshing this. It's a very nice article, but
It is a nice article, yeah. And I have another question on this fine-tuning what you have done for, especially for the non-compliance and the follow-up action.
Right.
So typically, how long did you take to fine-tune, and
Sure.
do you have any cost mapping?
Yeah, yeah. I think every experiment costs around $100 to $200 because you need H100 cards, you need minimally A100 cards, or at least 40 to 48 GB of dedicated GPU RAM. So that costs, and it takes a few days to get it right. You will go through many fine-tuning cycle. You'll iterate between knowledge distillation, data denoising, machine learning, Rouge score metric analysis, repeat. You'll go through that cycle many times. I would say $100 to $200. That should be good enough to create a model. One experiment, that's what it costs. Takes about a week, to complete one feature and add that to our suite of capabilities. Yeah.
Okay. And sorry, I'm taking too many questions.
Please go ahead.
Yeah. The third question is, after you have fine-tuned and productionized your model, so once it's productionized, how many user queries or how many number of queries that it could take, and
that's a good point.
what's the cost involved again on a daily basis?
Sure. So that's a great point. I wanted to touch upon that. So you can actually fine-tune ChatGPT. There's a particular syntax you have to follow where there's a key JSON format, and then you have a text and the completion keys, and then you have to provide your annotated data set. And you can fine-tune. The fine-tune variant will be associated with your subscriber ID, and you can always access it and use it. They take care of all the load balancing, so you don't have to worry about the load balancing part and the inference time, latency and all of that, they handle it. With Flantify, the deployment strategy. So whenever you create these models, the creation of the model is interesting, it's fun, but there's a lot of pain points when you try to deploy a model, okay? So all of these models have been wrapped up as Flask APIs. So that's our go-to strategy, and we deploy it using our pipeline, and it's cloud deployed, and we have the endpoints. So the endpoints can be hooked to your dashboards quite easily. The latency, we are noticing around 10 to 15 seconds per request, but then we also need a cluster, a load balancing cluster. So all the load balancing would have to be handled by the dev team. It's not automatically handled by any organization like OpenAI, because we are not using proprietary LLM APIs. Yeah. So we also have high-end workstations that we procured. We are going to set up our own cluster, and we're in the process of actually setting up, installing all the libraries and dependencies and getting it ready. So once that's ready, your requests will actually be handled by your on-prem cluster as well. Right now, it's a secure cloud cluster that we're using. Yeah.
Okay. And cost on the number of queries the user.
On a per query cost.
Daily basis.
You'll have to come to our booths. We've got the numbers. I'll share that with you. Yeah.
Okay.
But it's not that expensive. Costs. Getting availability to those H100 cards is a problem. Availability is very low. I think you must have heard about it, right? They are very rare, to get hold of. And once you get hold of it, you don't want to release that instance.
Right. Yeah. Thank you so much.
Hello, I have a question.
We'll take this one and we'll come to the next one.
Yeah, hi. So did Synechron have to negotiate a separate licensing agreement with OpenAI? Because I'm not sure if, say, distillation is against their terms of service.
Not really. They have the APIs. ChatGPT has opened up all the APIs to do fine-tuning. Knowledge distillation. Is it really against the terms and conditions?
I mean, it says on the terms of use that as part of the restrictions.
Can you show it to me?
Sure, yeah, we'll meet up.
I'd love to be in compliance.
Yeah. Thank you.
Can I go next? Hello?
Yeah.
So one thing is, if ChatGPT's terms and conditions are very restrictive, we can go with Azure OpenAI. We have an Azure OpenAI account. We're also in the pipeline, in the queue waiting to be approved for the enterprise license for ChatGPT. And we have an Azure OpenAI subscription, so we could use that. And they've recently opened up fine-tuning in Azure OpenAI. We got the message. So that's one way to go. Otherwise, you can have a Llama model okay, with 70 GB, the largest one, running on-prem, and you can actually use that for knowledge distillation. So there are many ways to handle this. Yeah. Yeah, but I have to read the fine print. Thanks. Yeah. Yeah.
Okay. Hello.
Yes.
Yeah. Okay. Great session. Thank you for this.
Thank you.
I have a question around translations. I saw in some of the use cases it was showing, I think it's audio and text both, right? The conversation that was happening with the customer.
Mm-hmm.
So in terms of translation,
right.
how is your experience with, capturing the accent of the people? Because your customer can be globally located, right?
Right.
And then in the conversation, people generally use the local languages as well. So how is that translations captured and then this impact the summary and other processes?
So, yeah, great question. Normally, when you try to build an application for like contact center modernization or customer support automation or CRM systems, you'll find that each of the customers will have their own preference for like a speech-to-text vendor, somebody who's already doing that. That part is, they've got that covered because it's tightly integrated with the IVR and voice over IP system and all of that. Wave-to-wake models from Meta, you got Whisper from OpenAI, right? So they're really cutting edge. So they compensate for all the variation in the accent. So we've actually seen even Teams doing a brilliant job of transcription in real time. Near real time. It actually chunks 3-4 seconds and then gives you the transcription, and it works quite well. So there will be some element of error, and there are models to also, spell check and auto spell check and things like that we can use. Yeah. But that part is already, it's out of scope for our project because many vendors actually use their own speech-to-text transcription. And that's an area if we wanted to go and we'll use Whisper or Wave-to-Wake or any of these models. Yeah.
Hello. Thanks for the wonderful session.
Sure, thank you.
Could you please throw some light on the general guidelines for preparing the data for the fine-tuning? So what are any guidelines?
Right. So the Samsung dataset actually has a split of train, test, and validation. We go through a similar stratification of the data. We'll do that. Some of the things that I didn't touch upon here are all your parameter-efficient fine-tuning and things like that, which are the internal, mechanisms of how you achieve this. Okay. As regards data preparation, is there anything specific you wanted to ask regarding that?
Sample size and the quality.
Yeah, sample size. There was a question here. We worked with around 2,000 samples, and that was good enough to produce these kind of benchmarks. But these numbers. But I would, if I had more time, I would actually. Spend more time in augmenting the data than work with a much smaller data set. Yeah. So that's.
Hello.
No, we don't do this manually. So what I showed you on the